This video is to serve as an introduction to exponents beyond just squares and cubes. We'll look at what the expanded form of exponents looks like, as well as evaluating exponents and looking at the difference between positive bases and negative bases. Before we begin, let's look at some vocab that you'll hear a lot in this unit. First off, the theme of this unit would be exponents, and those are the little numbers that you see raised up next to a term. Sometimes you'll also hear these called powers. Now the term right next to the exponent is called your base. So here the x is the base of the exponent of 2. Since the 5 is not directly next to an exponent and there are no parentheses involved, 5 is something you hopefully are familiar with of a coefficient. We'll also see plenty of examples such as 5 squared, where a number like 5 can also be the base. In this unit, we'll be looking at exponents in a lot of different forms and notations. The three most common would be expanded notation, exponent notation, and standard form. So in this example, we have 2 to the third power, or 2 cubed. Now, that's actually already given to us in exponent notation. Expanded form is showing what 2 to the third power actually means. So if we think of something that you hopefully know of squaring, we know that means multiplying a number by itself. So an exponent shows how many times that number is getting multiplied by itself in total. So 2 to the third power expanded out would be showing that that means you're taking 2 times 2 times 2, a total of 3 times. Standard form is actually getting an answer for what that's equal to. So 2 times 2 is 4, times 2 again would give us 8. Now all three of these forms are equivalent or equal to each other. It's just a matter of what form or notation is the most beneficial to you. Let's look at different examples of going back and forth between these forms. If we start with an exponent form of 3 to the 6th, expand it out, and what that really means is happening is 3 multiplied by itself a total of 6 times. So usually we see 6 3's being multiplied together. Evaluate it out on your calculator. You can use the caret button, which looks like a little arrow, and then whatever exponent you need. So 3 caret 6 to give us an answer of 729. Again, all three of these forms are equivalent or equal in value. If we see something like 4 times 4 times 4, we can evaluate that as equal to 64. The other way to look at that would be to write it in its exponent form. So 4 is your base, and it's happening a total of 3 times, so 3 would be your exponent. The last one is negative 2 to the 4th power. Again, what that means is happening is negative 2 multiplied by itself a total of, 4 times. So if we were to evaluate that, you would actually need to use the parentheses on your calculator to do that. We'll talk about why here in a second, but negative 2 to the 4th power would equal a positive 16. If you're wondering why it would be positive, we can look real quick that these two would cancel and these two would cancel, leaving you with a positive answer. Let's explore more on how negative bases or positive bases affect your outcome. So the base and the sign of the final answer all depend on what type of exponent you have. Let's explore with smaller exponents such as squared and 3 with a positive 4 and a negative 4. 4 squared, by definition, expanded out means 4 times 4. So we can see that that answer would be 16. Negative 4 squared would mean negative 4 times itself. So negative 4 times negative 4. And we see that those two negatives would cancel, leaving with a positive 16. 4 cubed would mean 4 times 4 times 4, a total of 3 times to evaluate to 64. If we had negative 4 cubed, that would mean negative 4 times negative 4 times negative 4. So here, our first two negatives would cancel, but then we have that third at the end. So a negative 4 cubed would actually give us an answer of negative 64. So in general, if you have a negative base with an odd exponent like 3, 5, or 7, that's going to give you a negative answer. The reason for that being everything's going to partner up and cancel except for the one left over at the end, which would turn your whole answer negative. Whereas an even number of exponents, so like 2, 4, and 6, would give you a positive answer since everything is pairing off and canceling out. Be careful with these problems and negatives because, believe it or not, the first two problems actually have different answers. If we think about the order of operations, or PEMDAS, what's going to happen is that exponent is going to get evaluated first. So if you type these two into a calculator, your calculator is going to tell you that this has an answer of negative 16, where the second one has an answer of positive 16. If we think about why, your calculator is evaluating the exponent first. So it's going to square 4 and then make it negative. Whereas in the second one, it's squaring the quantity of negative 4. So more so looking at negative 4 times negative 4 versus the negative 4 times 4. So just be careful with the way the problem is written because these two might mean different things. Whereas if you have an odd number exponent, these two would be equivalent because we know that an odd number of exponents would still give you a negative answer, just like something like this would as well. So be careful, parentheses matter and they do make a difference. So if you see them in the problem, make sure to type them that way on your calculator.